Okay. Hello, everyone. Welcome to today's webinar. I'm Erin, Operations Director here at Softree, and today we're talking about a slightly different but road-related webinar topic. We're going to be tackling transmission line projects. And as many of you know, RoadEng can support these projects, really focusing on that sort of road design, pad, earthworks side of the transmission line. So if you're here and you're expecting us to talk about anything electrical, that's not our thing. It's all about earthworks. Before I get started, a couple pieces of housekeeping. First and foremost, you're muted. You're going to stay muted the entire webinar, but you are welcome to ask us questions, engage with us through that Q&A section of your GoToWebinar panel. And if you're watching this off of YouTube in the future, hello, and you can type questions in the comments section below, and we do respond to them. With me today is my colleague, Matthew Dickey. He's going to be doing all of the heavy lifting in today's presentation. I'm just going to give you a quick introduction to sort of the four key areas that we're going to step through in today's workflow, as well as a little bit of background. So to get things started, resource road networks. We are talking about, obviously the transmission line context today, but there's a lot of similarities between wind farms, forestry operations, and transmission line projects. So if you happen to be in one of those adjacent industries and adjacent resource road networks, a lot of what we're going to cover today from a content and workflow perspective very much applies to your types of projects too. All of these projects are low volume road networks. They've got landings or pads that are tied and connected into roads. And the location of the road is really influenced by other aspects of the project. Now, in the case of transmission lines, the right-of-way is a pretty big one that we will focus on showing you today, as well as some other constraints, existing infrastructure considerations, as well as environmental concerns, whether that's stream crossings or etc. And finally, all of these projects tend to be pretty time and cost sensitive. And that's where using RoadEng to really jumpstart those projects, help you get the road in the right place, minimize those earthworks can really go a long way. So today's workflow, or agenda, if we want to call it, is really going to be focusing on that long linear transmission line corridor, some, relatively fun terrain, bringing in our actual transmission line towers, then building that terrain model based on some LiDAR and DEM. Then we're going to use Path Explorer AI, and I should say this is going to be an alpha version of 12 coming out into beta within the end of the month. So we are, previewing and working with our new version. And yes, if you have been in a webinar before, we've talked about 12 for a while. We are excited. It's almost at the finish line. So today, again, we're going to be playing in 12 new networks functionality in Path Explorer. It's really phenomenal way to evaluate not just a singular road, but an entire road network as it applies to those transmission towers and the access alternatives for getting to them. From there, we'll take it into our second module, because we are modular, and do the actual proper full road design, as well as get some, earthwork volumes, construction documentation, etc. So as I said, terrain model, essential first step. And to do this, we're going to bring in some data. Now, typically for these types of projects, we're working with higher resolution data, whether that's LiDAR, DEM, drone data. And our big point here, we do tend to try and keep our modeled points below 10 million, or essentially 1 million points per gigabyte of RAM you have on your computer. We do encourage you to leverage different thinning tools to control that point density, because these projects can be long and can have a lot of data if you keep everything at full resolution. So leveraging an AOI, as I've shown here in magenta, really helpful in terms of controlling that point resolution and making sure that your model still operates fast. So after we've brought in the data, step 2 in our webinar today is Path Explorer. And this is going to be Path Explorer Networks. So Path Explorer, if you're not too familiar with it, it's our AI tool. It's built inside of RoadEng. It actually runs completely local on your computer, which is awesome. So your data is not going to a cloud. And it's going to, consider different factors, so your road width, your grade, side slopes, as well as other geometric constraints. And then it's going to look to connect all of your points in your road network, or points to a road network. So in this case, putting all those transmission lines, picking out the main line, as well as the spur roads. And It's doing so and thinking about it in a very 3D road specific way. It's not just looking at what's the shortest way to get from A to B with, these grades. It's actually looking at a simple trapezoidal prism. It's looking at your width, your slopes, as well as costs. So we look at a surfacing cost, a cut cost, and a fill cost. And it really allows you very quickly to figure out on a landscape where that road network should go. But for transmission lines, a really big, important part is bringing in some of our constraints. And we're going to do that through something called construction zones. A few examples here on the screen. First and foremost, stream crossings. This one applies to pretty much anything we tend to present about Path Explorer. Certainly assigning a cost every time you cross a stream. So here we're going to use our polylines construction zone. Then we've got our right-of-way, and we can handle this in a couple different ways. We can assign the right-of-way outside the right-of-way as simply a no-go area, or we could assign a polygon outside the right-of-way that maybe has a different cost. So if you have a very, very narrow right-of-way and some areas where maybe a road isn't even feasible, if you stay within it, you can make outside of that right-of-way boundary a different cost. We've also got existing roads, and this is another new feature that's part of networks, but we can tell Path Explorer, hey, this is our existing road network that exists in this area, and maybe there's an opportunity for it to leverage that existing road infrastructure to reduce your costs and allow you to use that. And then finally, there's the other side of existing infrastructure, which in the case of twinning projects, and which is the example we're going to actually work through today for transmission lines, we can actually tell the Path Explorer, hey, there's existing transmission lines, there's existing infrastructure here. We can't cross it. And maybe we can't even come within a certain distance of it. And we can define those as no-go polylines and no-go polygons, and allowing Path Explorer to then work around it. The same can be done with other types of geotechnically unstable areas. Maybe you've got a protected habitat. Lots of ways to leverage construction zones in order to control the behavior and influence how Path Explorer behaves. So that's kind of the second part of our webinar. So terrain modeling, then we're going to go to Path Explorer, and then from there, we take it over into our second module, and we're going to do our detailed road design. So here you've got full road geometry, full 3D design. You're adding proper curves, volumes, templates. We talk a lot about this in our webinars, so hopefully you've seen it before. You're not, it's not too new for you, but we will step into that, taking our road network through and bringing it to life a little bit more inside the location module. So again, location's our second module, and it's got all the different interactive dynamic windows that allow you to create your full geometric design. And then finally, we'll probably not spend too much time on this part, but on an output side of things. So, at the end of the day, once you've gone through RoadEng, whether it's preliminary or whether it's detailed design, you've got your 3D model, with geometry that can be, exported out in digital documentation. You can send it off to another software through one of the common formats. We can get our material volumes. You can get a earthwork movement schedule and lots of different options. To then take it to the next step. And speaking of taking it to the next step, I'm going to turn my camera off. I'm going to pass it over to my colleague, Matt, and he's going to dig in live into the software as we tackle, for the first time ever in Softree webinars, transmission lines.
All right. So, as promised, we'll dive right in and we'll start from scratch. So, as Aaron mentioned, the software is modular. So we're going to start in terrain. And we're going to bring in our topo data first. So I'm going to bring in this DEM. And we can see our surface, so kind of setting the stage a bit for what we're dealing with today. Now this particular project, we'll just look at it kind of a small portion of a particular project, at least to start. So this particular project, we are dealing with transmission lines, and we have some proposed tower locations. So I'm going to bring those in, and just to make that visible, kind of set the stage, we'll make it so we can see what we want to see here. So we want to access these 6 points. And well, of course, we're going to want to start our road somewhere where we already have access to. So I'm going to and here we could draw it in just as easily. But just to bring it in and have a nice visual here, we're going to start it with a start point right here. So if we wanted to keep this bare bones, well, we could go up to the optimization tab and click Path Explorer, and we could put in all our design parameters that we wanted to for things like curvature, earthworks costs, etc. But aside from just knowing that we want to start here and get to these other points, well, there's a few other things that we're going to want to be cognizant of on this particular project. And that's where construction zones, as Aaron introduced, comes into play. So all those things that kind of deviate from our defaults, we can add that realism in here as well. So this particular project that we're looking at, it's actually a twinning of an existing power line. So we're going to add in the, and actually I think I clicked the wrong button. We're going to add in those existing tower locations. And again, I'm just going to make it so we can see them. I'll change the symbol from being a very small dot to something a little bigger. And these ones are existing. So I'm going to just color those as red. So we do not want to undermine those. And in fact, well, to give us a little bit more of a leeway, I guess, as we're dealing with it, rather than just saying don't go exactly at that point, I'm going to take all these features and I'm going to put a little bit of a buffer around them. On these particular examples, I'm going to say, well, I want to have a buffer 10 meters around these guys here. And obviously we're going to change our symbol. And that's going to be a no-go polygon where we don't want our road to go in there. Now, aside from just not wanting our road to go in those circles that we have, well, we've also got a right-of-way that we want to stay in, or I guess a proposed permanent area. So we have that as well. And again, if we wanted to, we could draw all this stuff in, but of course, a lot of the time it's pre-existing. So we'll bring in that permanent area. And once again, I'm just going to change my line work here so it's easier for everyone to see. They're using another kind of handy V12 feature. We can clip the draped features so they're not falling off. So we want to stay within that line, and yeah, we want to go from there. Now, aside from kind of just the actual transmission line spatial data that we want to consider, there's some other stuff that we'll want to consider. So in this particular case, we have an existing road. Well, we might as well consider that. We can use the existing road cheaper than building a new one, so we can dump that in. And well, we, aside from just considering our earthworks and these no-goes and roads, well, we've also got some stream crossings on this one. So rather than inserting data that pre-exists here, I'm going to just calculate those stream locations using the hydrology tools. And voila. So we've got kind of everything set up that we want to consider. And now rather than just saying, go from this point to these points, we're going to say, go from this point to these points while considering this other spatial information. So we're going to set up our Path Explorer run here. So I'm going to go up to optimization. We're going to click this guy here, and we're going to put in our design criteria. So I want to have I'll keep my minimum curve radius. I'm going to go with 30 meters for a minimum here. And I'm going to go quite steep for my road. So 18, now this is just kind of temporary access for construction. So we'll push the envelope with that 18% grade. We're going to set our other parameters, things like our cuts and fill slopes. And I'll set my road width. And of course here, where we're going to solve this as a network problem, I'm going to only produce one network option. So we've got kind of those defaults set. I'm content with everything else, my max cuts and fills, my earthworks costs, and surfacing costs. And then we'll go over to the endpoints. So in the endpoints, I'm going to say, well, I want to solve this as a network problem, not just stringing them all along the same road. And we're going to say, well, let's use that start point, and let's use those proposed tower points as kind of our destination. And we're going to move that start point up to the start, or up to the top of the list, I should say. And then we're going to go on to construction zones. So in construction zones, we're going to add all that extra stuff. So right off the bat, we've got that kind of permitted area that we want to stay within. So we'll select this guy. So for this, where our start point is inside of it and we don't want to cross that line, we're going to use a no-go polyline. And that's going to be an absolute. So if it had to go outside of that line in order to make this project work, it would come back as infeasible. But we could use like a softer way to handle that, and we'll talk about that a little later. So that feature is called permit area. Now the next thing that we're going to add in is the no-go polygons. So those buffered areas around my existing towers. Oh no, and here I forgot to give them a unique name. So just a sec here. We're going to just save this, and yeah. So these lines, just I don't want to make the dots no-goes. I'm going to just select those, and I'm going to select them based off that. And just so I can keep track of them, I'm going to call them no-goes. All right, back to where we were. So no-go polygons. Now that I know what they're called, those are the ones I want. And we're set. And then, well, other than these do not cross this line, do not go there, well, we have those streams that are going to cost more. And so rather than just being this absolute no-go, we're going to say the streams, well, they cost more. So we're going to use a polyline function or polyline feature. We're going to select all the streams. And we're going to say these streams cost $4,000 a pop just to get across them. And if we had rivers, we could make the rivers cost more. But yeah, they're kind of all the same or similar. So we're going to run with that. So we've got that. And then lastly, we're going to tell it that those existing roads are there and we can use them. So we'll add those in and we'll hit OK. And we're going to let this thing think. We'll hit OK. And we wait. And we shouldn't have to wait too long. It is extremely fast for what it is. But yeah, it's extremely fast for what it is. Not quite instantaneous. So we are going to have, yeah, maybe a minute or two while this thing chugs away to figure out how to get from our start point to our end point. And then where we need those spurs coming off, yeah, but yeah, we're 30 seconds in and already almost halfway through it. And now once this is done as well, of course, we could tweak things, adjust things. If there was something that, oh, I forgot to capture that, well, it doesn't take long to rerun it, adjust things. But yeah, hazard to guess, this is going to be a pretty reasonable solution right off the bat. All right. And there we are. So I've got my little stub coming off to access that one. We're only accessing the ones that are green. These other ones we wanted to avoid. We've got a little stub coming off there, and then we continue along to the end. So let's take this over, and rather than just having this really smart line on the map, let's take it over into location. And here I'm going to just do one more thing that's kind of optional, but I don't want my line work for the existing road when I take that over, so I've just broken it here. So we'll hit save as, and I'm going to just save this as my example terrain. And we're going to minimize this, and we're going to jump into that other module, which is, of course, location. So in location, we're going to take, again, that really smart line that's kind of searched around through 3D space to find the best location for our road. And we're going to turn it into a proper geometric design. So we're going to come in here. I'm going to grab that file that I just had open. I'm just going to start with one alignment here to start. So I've got that. We'll hit next. We'll hit done. And well, we'll hit zoom to extents. And we'll just, there we are. And here, just for context, and I didn't download it there, but I do have a background available. Let's throw in an image here. All right. So taking this line and turning it into a design, there's a few steps that we'll typically follow, kind of a rinse and repeat. Right off the bat, as far as our design is concerned, well, we're going to want to make sure that our cross-section geometry is appropriate. Now we can control that in our template. So I've got a collection of different templates here, and we can add to it. We've got lots of different components to account for various situations, but most of the time, the vast majority of the time for projects like this, it's just going to be the resource low volume road that's used. You may change things like your road width, surfacing depth, maybe your ditch parameters, but all of these really just act like a fillable form where we can come in here, change what we want to change, and hit OK. But you can, if you have something special, you can absolutely account for the something special. Now I'm happy with our cross-section template for this one. The next thing that I'm going to do is, well, we've got that solution that Path Explorer gave us, and it's considering our curvature as it created that line, but it's still producing a polyline. So to take this and turn it into a, let's say, a proper alignment with curves and tangents, we can come up here. So corridor, operation, whoops, and I clicked the wrong button. We'll go polyline to alignment. We're going to put in that minimum radius. We're going to give it a little bit of a tolerance to allow it to deviate from the current polyline a bit. And we'll let that solve, give us, well, take that polyline and have a nice tidy alignment with a few curves and tangents that adhere to our minimum curvature and our max offset. And this will just keep improving, but I'm going to be impatient. I'm going to hit cancel. And we've got the best it's found so far. So it would only get better from there. So we've got, well, a cross section that's appropriate. We've got our alignment that's appropriate, our horizontal alignment. The next thing that we can do is, well, we can tackle our vertical alignment. So here, we're going to come over here, and my vertical defaults are all set, but if they were different, I could change my grades to be whatever we'd like. We could add in different control points if there was somewhere where we wanted to be at a different elevation than what we have. When we do our vertical optimization, it's going to look at our earthworks cost. So we could add in a bunch of different materials and have different zones where say from station X to station Y, we have gravel over solid rock. Another area we might have deep hard pan. So we can assign all that and have different depths of those different materials. In this case, I'm just going to keep it simple. We'll have a single material. Again, we've got an earthworks cost for it for embankment and excavation. But well, one thing that this is considering, the Path Explorer is not, is our movement cost, and with that, the balance of our material. So we're going to consider even more when we run our vertical optimization here. And we can add in all sorts of extras like pits and constraints like full bench constraints, etc. But I think we can run with this and get a pretty good solution right off the bat. So we'll let this solve. It's going to think for a moment. Main line running through our project. Ta-da. And so I can see I'm dealing with 4,000 cubes of cut and fill. I've got 700 cubes for my surfacing. And there we are. We are set. And if we wanted to take this a little further, we certainly could. And I'm going to I'll do a couple extras. So 1, 4, and sure, we'll do 1, 6. So I'm going to just add in those additional alignments for my spur. There we are. So, and since our default cross-section is the default cross-section, we are set. The only thing that we'll want to repeat here is I'm going to run that polyline to alignment for that one. I'll run polyline to alignment for this one as well. And we'll make zoom to extents here. And then we're going to do our vertical optimization. And we'll come in here and, well, we might as well do a couple of these at the same time instead of just doing one at a time. Oh, and there we are. And this one here, I guess I'll just, yeah. So we've got 2, 1 there, and we've got, well, that network taking shape. So pretty slick, pretty straightforward. We've done a ton of heavy lifting here as I explained my way through it in a pretty short amount of time. The one thing that I will kind of add here is, well, if we wanted to, say, add in something, and right now we're just considering that road as a road. If we had something like, well, as we got out to the end of our alignment, we've got that tower location. Well, if we're designing this to build it, we may decide that, well, 1, we don't want to have the end of our road dipping off at 10% grade. And then 2, we may also want to have a bit of a laydown or work area. So there's all sorts of different ways we can tackle our pads or work sites. And we could do the pad as kind of its own standalone entity in terrain if we wanted to. Or we could do something a little more complex like we do in our standard wind farm design workflow, where we basically position these relatively complex geometries for the pad laydown, and that has a boom area, areas to store things. So we could do that. But in this case, kind of anticipating just a rectangular pad being the best fit for the site. So I'm going to use an override. I'll come up here, I'll say, well, let's override our road width. And I'll do this on the left side of my road. I'll add that widening in at 9 to 80. So 980, I want to keep that default width. And then we'll have a pretty tight transition 985. We want to bump that out to, say, let's go 20. And we'll carry that forward to just shy of the end. So, and we'll go 10:05. And and we'll keep that 20. And then, yeah, we'll taper it back really quickly by 10:08. And there we are. So we'll hit OK. So right off the bat, that gives us this bump out. Now the kicker here is, well, we want to have that reduced grade. We might want to do that somewhere else as well. So on this particular site, I've got another location here. So at 740, I want to have that same setup. I can just click duplicate. We'll set that back, centered at 740. And there we are. And well, here we're on that crest. I actually like that quite well. It'll drain well. But over here where I'm at that grade, well, we could manually adjust it. So as we're using Path Explorer and the Vertical Optimizer, we're not stuck with that. We can make whatever changes we'd like if we're doing that with the mouse. Or it could be something like this where I've decided that, well, it warrants rerunning this, and I want to have this end on a tangent that's less than 5%. So I could come in here, we could rerun it with a different constraint. So I'm going to say from 980 to the end of my road. I want to have that on a vertical tangent. I'm going to keep my grades to be less than 5%. Click Add Edit. Click Process. Let this thing go. And we'll redo that optimization, taking into account that extra realism that we just accounted for to give us a reasonable work site to build what we want to build. And there we are. So we've got that grade taken care of and optimized with all the earthworks that we want to consider. Now, of course, with this, we could go over and we could create our documentation. And I'll just do a simple one. So we've got that plan over profile or sections generated very quickly. Or if, I'll just close this, if we wanted to, we could well, export this out in a variety of formats, including, well, land XML will be a big one for machine controls, construction staking, modeling, etc. But yeah, we could write to, say, shapefile for the GIS people. And yeah, that's our core workflow. So pretty slick. And with this, of course, we've kept it quite small here. We've only tackled half a dozen tower locations. But hopefully this is, I guess, digestible and kind of articulates the what it can do without being too much to look at. Now, this particular example that we're looking at is part of a bigger project. And kind of, well, Aaron alluded to it, where in this case, we ran it with that permitted area acting as kind of an absolute don't go there. So all of our options have to stay within that. And we also ran something that only took, what was it, a minute or so, which of course is nice if you're in my seat and showing this off. If it takes 5 or 10 minutes, it feels like forever. But we do have a bigger version of this project that we can kind of unpack and talk about some functionality or different strategies and how that looks with things. So I'm just going to open this in, I'll open it in terrain. All right, and I'm going to just go ahead here and see if I can get my bearings. Yeah, this was the site that we were just looking at. So kind of we came off here, came up there. So in this particular example, we have a few differences. So one, I've got a right of way that's much tighter. So it doesn't come down to the road here, it does back here. And it's just generally a much larger project. So instead of just looking at this particular area, we've got this whole area that was set up with the same kind of process. Instead of having my start point up here, I put my start point in here and told it to go to, well, I think there's 40 some tower locations here. So kind of, again, a much bigger site, kind of hard to just digest what's going on at a glance. But those Path Explorer features have already been run. So same buttons. And we'll pop this guy open, make them visible. So that's the kind of the new roads. I've also got the portions that are using existing roads. Somewhere in there. So we're going to make these all visible. And well, what did it do from this particular start point? Well, it went to these two kind of easy to get to spots. And then, well, it has the smarts to recognize that one, it's very difficult to get down that slope. So instead it came around and used the existing road. Now, the other thing that I did differently with this one, again, Aaron introduced the concept, but we've got some very steep pitches here, and I was kind of cautious with saying, let's use a 30-meter radius. And I've got a 5-meter max cut and fill height. So in order to make some of these grades work, I didn't want to just limit it to have massive cuts and high costs. Instead, I said, well, let's assume that we can go outside of that permitted area a little bit. So here in my kind of defaults, I assumed a high surfacing cost everywhere else, except in that permit area, I gave it a lower cost, so it would favor that solution. So we've got stuff like this where, well, we can see if we can maybe negotiate with the neighboring landowner to go a little bit outside of what's pre-existing. And that gives us a lot of flexibility. So, well, it'll do things like this. And then, well, coming out of here, we can zoom out. And again, this example, well, it's got this big ridge here where that's kind of isolated. We've got this big drop that's quite steep coming off of there. So if we had to stay in that little tiny width, again, big cuts, big fills. So we used that permitted area as kind of a soft constraint. And instead it says, well, we've got existing roads here. Let's go up there. Comes to that point, splits off, hits all the transmission lines that make sense to hit. And voila. So I said that I didn't want to run this live because it took a little while longer, but obviously much larger. And this one only took 6 minutes to run, but depending on the the settings I used, it did take up to 20 minutes while I was kind of clicking around with it. So yeah, as someone that gets to see this stuff come together, it is awesome. And yeah, with that, I'll quit rambling and open it up for some questions.
Awesome. Thanks, Matt. So we covered a lot of ground literally inside that webinar. In the chat, a bunch of questions. And for those of you here in the live webinar, I certainly encourage you, type them in. You're going to remain anonymous as we address them. And we'll get through as many as we can in the next 5 minutes. So our first question, Matt, is there a way to automatically identify alignment sections driving the most cut and fill?
Perhaps. So I guess it depends how you want to define that. And I guess where you want to define that. So, and I'll go to the smaller example. Everything's going to translate from one versus the other. If you're kind of scoring how these relate to one another, we can select the features. We've got the XPath feature and then a number that comes after. So the number that comes after represents the cost. So that cost is going to be driven by your earthworks. And with that, I'd put a little bit of an asterisk on that. So at the Path Explorer level, you can kind of score it based off, the cost, but the cost is going to combine everything. Now, once you get over to location, well, then it becomes much more tangible and easier to define things. So on this one, we've got our road. So I've got my main road here that I've got, how much cut? I've got 4,600 cubic meters of cut. This little spur coming off, we've got 500. This little spur coming off, we've got 1,000. So we can really quickly set up those, look at our volumes. And again, and I won't kind of harp on it too much, but we've also got the ability to do an alignment summary in version 12, where we can summarize our earthworks by alignment. So we can really quickly just, how much does this one require us to move? So we can easily populate those values. Yeah, so hopefully that answers the question. And other than that, we can just visualize it. We've got the slope stakes, cuts, fills, profile. You can make other attributes to, if you wanted to base it off depth, all sorts of different things you can do.
Awesome. Okay, let's continue. I like the last question that came in. It says, for the bigger site, were you able to run Path Explorer for the 40 towers in one area in one time, or did you separate them?
No, I ran the whole thing in one go. And I was kind of grinning ear to ear when it only took 6 minutes. But 6 minutes was exceptionally quick. Playing with different settings, I had it up to, I think, 22 at some point for the solve time. But yes, I did do it all in one run. And I'm ecstatic about the geometry that it produced.
And obviously 6 minutes is far too long for a webinar. It's like watching paint dry, painful
like
in the webinar context. Very good questions. Okay, let's tackle a couple more. Do you have a proper workflow to control the transmission tower pad slopes rather than include them in the road cross-section?
Yes. So it'll really, I guess, depend on how you want to tackle it. So the one, I guess, the most flexible option would be to do it in terrain and not really tackle it at all as part of the road. But if instead of doing, which one are we at? Instead of just doing a widening and extending that road out, a really common way to do that would be, we go into the eLibrary. And in the eLibrary, there's a miscellaneous components folder. And we have an option to, where is it? Pads. And so we can grab a pad. This gives us the flexibility to, have a different pavement structure, and that kind of using the term pavement loosely there, but different aggregate structure for our wearing course. And then we could come in here and we could adjust the slope independent of the road. So if we wanted to, and we'd probably go the other way with it, but just so it looks kind of drastic, if we wanted to tip that differently than the road, we absolutely could. And if it was an unusual shape, well, instead of doing a tabular offset, you could use a reference feature. And rather than, I guess, showing 5 different ways to do it live, we do run through that process. In past webinars and individual videos. Best source is probably one of the wind farm videos for those of you that might like more information on it.
Awesome. Okay, we're going to do one last question, which in this case is actually, there's 2 very similarly oriented questions. The first one, part of my project does not have LiDAR data coverage. Can I bring in a different data set? And the second question, somewhat related, I have coordinates taken from the field. Can I import them into the software?
All right, totally. For the portion without LiDAR, you can use whatever you want for topo data, provided that there is a X coordinate, a Y coordinate, and a Z coordinate. We can create something out of it to design with. It'll just kind of be up to you to decide whether or where that data comes from, whether it's a conventional survey, maybe with RTK. It could be, if it was preliminary planning, a lower res surface like a coarse DEM. There's various global data sets for coarse DEMs. So there's all sorts of flexibility there too. And if you happen to have something where you had some LiDAR, you made it through the kind of feasibility level and decided to get the LiDAR acquisition for the remaining area, and maybe if it was just a small area, you could combine that. And it doesn't matter if the LiDAR is from a drone, fixed wing, terrestrial, etc. You could add that in after the fact as your project proceeds, and you get that better data for going to construction. So that's hopefully the answer for the LiDAR and the topo data. For field notes and other spatial information, if you want to bring that in, you absolutely can as well. And probably where Aaron was going with that, but if you have field notes, there's all sorts of options. You could combine the two. If it was really coarse and you just had like a hand traverse, you could take those field notes in the traverse module and bring those in, populate things like ground type information. Or if it was just like GPS points, you could bring that in a variety of formats as well. So I think the most common formats for field notes brought in would be shape or KML, and you can just insert that into terrain, and you can add labels or symbology to kind of treat that however you like. So show a label that shows all your notes in it. So as you're designing, you can see what you want to see without having to dig through that other data set. I don't have a good example for this one, otherwise I'd show it.
Okay, guys, 3 minutes overtime, which is actually, if you've been with us for Softree webinars in the past, that's actually pretty awesome. There are a handful of questions left in the chat. We'll take some of those offline as some of them are a little bit more training and licensing specific. And with that, thank you, Matt, for today's presentation. Thank you, live webinar audience, for being with us here today. And thank you to those watching this off YouTube in the future. If you have any other questions, please do reach out to our team here at Softree. We loved presenting this one. We are thrilled to be putting that new Path Explorer network tool out very shortly into the hands of customers through our beta program. If you are interested in participating in the beta, it is something that any customer on support that is willing to provide feedback is welcome to join us. And you can certainly reply to the follow-up email you're going to get for the webinar in order to get on board and join us for that program. Okay, that's it. Thanks, everybody. Have an awesome rest of your day.
Thanks, everyone.